So the next part, we'll talk about using calculators. So we talked about special triangles, but not all the time will we have special triangles. Now, calculators have two different inputs for your angle, degrees or radians. So make sure you check with your calculator that, or even if you're using some sort of internet thing, that your settings are to the proper degrees or radians, whatever the angle is that we're using in the problem. Now, some calculators have a function for all six trig, but some only have a function for sine, cosine, and tangent. And sometimes they're written, in just capital letters. Well, there's no difference in cosine, but tangent would look like this. And so if we're given something like this and we don't have a button for cosecant, secant, and cotangent, remember our identity that if we're trying to find cosecant of theta, we can just say 1 divided by sine of theta. So on your calculator, if there's no button for that, you just write 1 divided by sine of theta. And then same thing for secant of theta, you write 1 divided by cosine of theta. And then for cotangent, we write 1 divided by whatever tangent of theta is. Now we're going to talk about solving right triangles. So let's consider this right triangle on the right, where the base angle is alpha, the angle on top is beta, our length on the bottom is b, and then our vertical length is a, and then our hypotenuse is c. So since we know that alpha and beta are complementary angles, alpha plus beta is equal to 90 degrees. So that's one thing that we can use to help us. And also because this is a right triangle, the Pythagorean theorem gives us that a squared plus b squared equals c squared. So these two pieces of information can be really useful when trying to solve a right triangle. Now, to solve a triangle, so if you see this, to solve a triangle, what this means is to determine the values of all three lengths of its sides and the measures of all three angles given some information about the triangle. So, for example, if we have a right triangle where the base side is 16, the opposite side is A, our hypotenuse is C, we have an angle on the bottom, 50 degrees, and then our angle on top is beta, and we're asked to solve the right triangle. Then what we're going to do is we use the pieces of information we know, and so we know as well as the useful things. So our sum of our two angles is 90. Alpha plus beta is 90. In this case, we know alpha, so 50 degrees plus beta is 90. If we subtract 50 degrees from both sides, beta is 40 degrees. So now we know beta. The other things that we need to know, so now we know all three angles. One angle is 90, one angle is 50, and then beta we just found to be 40 degrees. So make sure that you see that that is a 4. Of 40 degrees. Now, we need to find all 3 sides. We only have one side, and that is 16. So what do we do now? Now, for our sides, we have an angle, and we have, in fact, we have 3 angles, but we have if we just look at our angle from the bottom, 50, and we do know the adjacent side, so we can use our trig functions that relate to adjacent. So we have the options of either saying tangent of theta is a over 16, which is opposite over adjacent, or cosine of theta is 16 over c, which is adjacent over hypotenuse. Just because I wrote this first, we'll go ahead and solve it with tangent. We could have solved it to solve for c. Either way works. We know our angle, instead of theta, it actually should be 50. So tangent of 50 degrees is a over 16. Solving for a, we multiply both sides by 16. So we get a is equal to 16 times tangent of 50 degrees. If we put this on our calculator, what we're going to get is that a is approximately 19.07. So now we know a. We also have our angle beta. So the only thing we have left to do is find our third side, c. Now we can definitely use this formula. Cosine of theta is 16 over c, and solve for c, and we knew that theta was 50. But a nice and useful thing is that because this is a right triangle, and only because it's a right triangle, can we use the Pythagorean theorem? A squared plus b squared equals c squared. A is 19.07. B is 16. And so 19.07 squared plus 16 squared gives us c squared. That adding these two together, the left side, we get 619.66 is about c squared. Taking the square root, we get c is 24.89. This is more of an approximate. So here we go. We solved the triangle. We found the remaining sides. We were given one angle, 50 degrees. We were given another because it was 90, a right angle, and then we're given one side, 16. All right, so now we're ready to go back to the problem that we first proposed when talking about right triangle trigonometry, and that's how far have we deviated if after one day we realized by using stars and other clues that we are off course by one house. Now, one house is 11.25 degrees. If, let's say, we traveled for one day, so in one day, usually we travel about 120 nautical miles. Okay, so we know that this distance would be 120 nautical miles. What is our deviation? How far are we off course? So let me redraw this triangle. Okay, so we have a right triangle where the hypotenuse is 120. That's how far we've traveled. We know that our base angle is 11.25 degrees, and it's a right triangle. And we want to find how far we've deviated, and let's call that y. Okay, so how far off are we from that reference course? Well, the function that we know, the trig function that relates from our angle, the opposite side, and the hypotenuse is going to be sine. sine of 11.25 degrees is opposite over hypotenuse. In this case, opposite is y, and hypotenuse is 120 nautical miles. Multiplying both sides by 120, we get y is equal to 120 times sine of 11.25 degrees, and our units would be nautical miles. So go ahead, multiplying this out on the calculator, sine of 11.25 and 120, we get y is approximately 23.4 nautical miles. So if you've deviated from one house after sailing for 1 day, will be 23.4 nautical miles off course.